Hello students and welcome to this calculus video. In this video we're going to begin practicing using the second fundamental theorem of calculus. We're going to go over some examples from the previous video. We're going to look at some new examples today. So let's get started. Here in the top I have the fundamental theorem of calculus. That's what we're going to use. These problems on the left side, these are all problems from the previous page, from the previous video. So they're already inserted here into this table. And what I want to do is I want to apply the second fundamental theorem of calculus to see if it's going to work. And we're going to get the same values. So let's go ahead and do that. So in this first one, if I want to go directly to f prime, right? I don't want to go through the whole process of substituting in the value. That can be very tedious. So we want to know, all right, what does the second fundamental theorem of calculus help us with here? I'm going to substitute the x in for the t's. So I'm going to get 4x minus x squared, just like that. And I'm going to multiply this by the derivative of that upper bound. So times 1. So because the derivative of x is 1. So this comes out to be 4x minus x squared. Notice that's exactly what it should be. So you can see like the second fundamental theorem of calculus gets us straight to the answer. So let's go ahead and I'll have you guys just go ahead and do the second problem real quick. And like I said, real quick is the exact same thing happening. You substitute in that upper bound and then you multiply by that derivative. Now let's see how it's going to work and when that upper bound is not going to be something like x, right? What if it's x squared? We're going to go through the exact same process. So let's go ahead and find f prime of x here. Well, I'm going to substitute in the x squared into that t. So it's going to say x squared to the third, and then I'm multiplied by the derivative. Well, what's the derivative of x squared? Well, that is 2x. And so x squared to the third is going to be x to the sixth times 2x. So x to the sixth times 2x gets me 2x to the seventh, which is exactly what we had before. But notice that we don't have as many steps as we had to do over there. Like that was a lot of process to get x to the 8th over 4 minus 1/4, right? And then to simplify, this one gets, the second fundamental theorem of calculus gets us straight to the answer. So let's go ahead and do this last example. Go ahead and try it yourselves. What I notice here is that I don't have to go through the entire process of working with the square roots, because that can be pretty tedious when you're working with derivatives and antiderivatives and such. But with the second fundamental theorem of calculus, it actually made this problem a lot simpler. So let's go ahead. We've got a few more examples here that I want to take a look at. In this first example, let's go ahead and do this because it's a new problem. So, all right, I want to say, all right, we're going to find the derivative. Okay, I'm going to substitute in, and it doesn't matter what the lower bound is. As long as it's a constant, it doesn't really matter. And with that 2x into that t squared, so let's write this out. That's going to be the square root of 2 minus 2x squared times the derivative of that upper bound. So that's derivative of 2x, which is 2. All right, so I'm going to get the square root of 2, and then 2x squared is 4x squared times 2. So I'm just going to put that in front of the radical. And there's nothing I can really simplify inside of the radical. So this is going to be my final answer. It gets us straight there. We don't have to deal with this with the radicals. And you use substitution, which you're going to learn about in this module. And so that makes it a lot simpler. And I also want to come in and I want to tackle this second problem together real quick. What I notice is that my constant is the upper bound and my function is the lower bound. And the second fundamental theorem of calculus states that those should be flopped. Well, because we learned about properties of derivatives before, we know we can swap these. All you need to do is make the entire integral negative and then you can swap it. So now I have negative 3 2x squared. Just don't forget that that negative is there. In fact, I'm going to make it a different color because I don't want to forget that that should all be coming out to be negative. So e to the cosine of t dt. All right, let's go ahead and follow through now and see if we get the same answer. All right, and then once you actually flip those bounds of integration, you're actually good to go. So keep that in mind, that the function always needs to be that upper bound. If it's not, just flip them and you're good to go. Just make sure that you have a negative integral in the end. So negative 2x times e to the cosine of x squared. Go ahead and attempt this final problem on your own. All right, and that is going to be the final problem. Just go into the exact same process. Make this a compositional function, substitute in the upper bound into the integrand, and then multiply by the derivative. It's very, very simple. It's just really a couple of steps that you have to complete. And it's just applications of previous things that we've learned from there. So of course, if looking at these last 3 problems, I know a lot of calculus students who would look at some of these problems and just freak out, but you see that they're just a couple of applications of things that you've learned here in this program. You guys are not going to be the students who are going to freak out when you see a problem that looks like any of these, because it looks a little bit weird, but you are prepared and you are able to do it. Of course, if you do need any help on any of these problems, you're not sure how we got them, please reach out to me so I can help. I'm Mr. Hernandez, and this is Mr. Hernandez Teaches.